This is Algebra 2, Chapter 13, Section 1, Part B, in which we will study more about trig identities. Remember last time we worked on finding values for trig functions. We used Pythagorean identities and the reciprocal identities. Now, today what we're going to work on is using the identities to simplify things. We're going to try to get things down as simple as we can. We'll use some of the identities that we used in 13.1a, the reciprocals and the Pythagoreans, and we'll use these new ones here. Okay, I've got these in radian mode right now. The same idea works in degrees, but it would be 90s instead of these pi over 2s. Okay, these are really nice as they relate to cofunctions. Sine and cosine are cofunctions of each other. Tangent and cotangent, secant and cosecant. If you have pi over 2 minus x and you're doing the sine of it, what you end up with is cosine. If you're dealing with cosine and take that, you end up with sine. So pi over 2 minus x is a nice little expression that you can use to switch from one function to the other. Similarly, tangent and cotangent are cofunctions of each other, so pi over 2 minus x switches one to the other. Secant and cosecant also are in that same deal. And the other set of identities we're going to add in are the negative identities. Some people call these the even and odd identities. Okay. Sine of negative x is the same as negative sine x, and its reciprocal is in the same boat. A negative inside can just move to the outside. I'm going to jump down to the tangent and cotangent because they're also odd. The negative on the inside can move out. Secant, or cosine and secant are even functions. You can just take the negative and stick it in your pocket and save it for later. Of course, that could lead to you being a bit negative down the road, but that's okay. A little math humor. Very little. So we're going to make use of some of these identities to try to do a little simplifying. Right? They've given us this expression, sine x times cosecant x over cotangent x. Now when you work problems like these, you're going to want your 13.1b note sheet in front of you because it will have those cofunction identities and the even odd identities. And you also want your 13.1a that has the reciprocal identities and the Pythagorean identities. Sine and cosecant. Well, I remember something about cosecant being 1 divided by sine. So I'm going to take cosecant out and substitute 1 over sine in its place. Well, something times its reciprocal, sine x times 1 over sine x, is just 1. The sine x's cancel out. So I have 1 over cotangent x. And on my 13.1a sheet, I have an identity that says 1 over cotangent x is equal to tangent x. And that's as simple as you can get it. You've got it down to one function. Okay, let's look at another one. This one's a bit more complex. Not a lot, but enough to get your attention. All right, we have tangent squared x times cosecant squared x minus 1. Well, I know that tangent and cosecant both can be rewritten. Tangent x equals sine x over cosine x, so tangent squared would be square those. Cosecant squared is 1 over sine squared. Now these guys cancel out. Guess I could have done that for you up here too, now that I think about it. Okay. But these guys cancel out. So what we're left with is 1 over cosine squared. Well, that's secant squared. So we have secant squared minus 1. If I divide secant squared into both of these, the secant squared cancels the secant squared and leaves 1. And I have 1 over secant squared over here. Well, 1 over secant on my 13.1a page says is cosine. So I have cosine squared. Now I'm going to stop and think about my Pythagorean identities, because after you've done enough of these problems, you see this and you automatically are thinking something. That looks Pythagorean. So I'm going to think about a Pythagorean identity. If I subtract the cosine squared over, that leaves sine squared. Okay, if I make this side of the Pythagorean look like what I have, I can substitute in sine squared. Okay, the secret to these kinds of problems is to be observant, to think about what the functions are that you have out there so that you can work with them. Okay, and the best way to get good at these is experience. It's kind of like the way to get to Carnegie Hall: practice, practice, practice. And it's going to take some work on your part to get through these. But you can do it. I believe in you. Okay, let's look at this next one. We have sine of pi over 2 minus x times secant x. All right. Well, sine of pi over 2 minus x is cosine x. That's on our 13.1b page there on the first slide. Secant is 1 over cosine. Cosine x cancels cosine x. That's more like it. So we're left with nothing left but a 1, so the answer is 1. And let's deal with one more of this nature. Okay, we have 2 times cosecant squared x minus cotangent squared x. Well, I'm going to think about my Pythagorean identity again. This one I'm going to look at cotangent and cosecant's identity. So from 13.1a, I have this identity to look at. Well, if I subtract cotangent squared x over, now I have exactly the term that's in the parentheses. Right? This and this are a perfect match for each other. So I can substitute 1 in place of all that stuff. And 2 times 1, I believe, is 2. Okay? Like I say, you have to use your powers of observation. You have to look at what functions you have, look at your 2 pages with the identities on them, and find things that connect. It's going to take practice. You're going to be frustrated, but you're going to get through it. Okay? You have to work at it. Can't take the lazy way out of saying, I'll just skip this one. Pretty soon you've skipped your way to a bad grade. So stick with it, pay attention to what you're doing, and you can get through this. If you had questions along the way, hopefully you wrote those down. Bring them in with you, and we will see you in class.